Children, good morning. Refraction concept. Refraction concept. Earlier we studied reflection concept. The light is reflected in the same medium when it is incident on a reflector like a mirror. So most of the light is bounced back into the same medium. That phenomena is called reflection. Now we are studying refraction. Refraction means bending of light while it passes from one medium into another medium. So we need two media. That means a pair of media is required. So refraction concept is discussed only for a given pair of media. Now let us consider a pair of media. This is a boundary. It is a boundary, a line that separates two different media. One is called, say, air medium. So air. So between you and me, air is present. The light ray is traveling through air. It is now traveling through air medium. It is traveling light. It is incident. It is incident obliquely. That means it is making certain angle with the normal. It is incident. This could be a normal. So this could be a normal. This is a normal. N prime is a normal drawn in both the medium for this surface. So here xy is called interface of air, water, because second medium is water. This is the second medium. It is water. The speed of light in air is c naught, and the speed of light in water is, say, v. Remember, children, speed of light in air is always more than speed of light in water. That's why water is called a denser medium. It is called denser, optically denser. This is optically rarer medium. It is called a rarer medium. So now PQ is called incident and Q is called point of incidence. Q is called point of incidence. PQ is called incident light ray. That is called incident light ray. Of course, P is called source of light. Light is now proceeding from the source of light and is incident at point Q on this surface. Hence, Q is called point of incidence. From the point of incidence, the direction of the incident light ray from the point of incidence, the direction of the incident light ray changes because the speed of light in air is more than the speed of light in that is water. So under these circumstances, air into water, so definitely the initial direction of the incident light ray is would be this one, and it is now going to be changed. It is now bending towards the normal. Towards the normal that is drawn in the water medium. This is a water medium. It is actually a water medium. You can just take this as a water medium, right? This is what is actual direction of the light ray. This is what actual direction of the light ray. PQR. Say, what is QR now? QR is refracting ray. It is called refracting ray. Refracting ray is present in the denser medium. Incident ray is present in the rarer medium. Therefore, the refracting ray must bend towards what? Normal. So it is bending towards the normal. On the other hand, if the ray is traveling from incident ray is traveling from water into what? Air. That is from denser to rarer. So the refracting ray will be in the air medium and the refracting ray bends away from the normal. That diagram also I am going to draw it later now. So that is, this is now called regarding the angles. Now the angle made by the incident ray with the normal is called angle of incidence. The angle made by the refracting ray with the normal in the denser medium is called angle of refraction. This is called angle of refraction. And the deviation that is suffered by the ray from its original direction, this is the original direction. This is the deviation suffered, called angle of deviation. It must be angle of deviation. So angle of deviation, so let us calculate after knowing the laws of reflection. What are the laws of reflection? The incident ray, refracting ray and the normal that is drawn to this interface must lie on the same plane. As usual in the case of reflection concept also, we studied the first law of reflection as incident ray, reflecting ray, both are lying on the same plane and normal. So here also incident ray, refracting ray and the normal drawn to this pair of media, that is for the interface, must lie on the same plane. So then second law of reflection is the ratio of sine angle of incidence to the sine angle of refraction is a constant. Or we can write sine angle of incidence is directly proportional to sine angle of refraction. Sine angle of incidence is equals to some constant of proportionality defined for second medium in which refracting ray is present with respect to the first medium. This is therefore called refractive index of the second medium. This term is called refractive index of the second medium with respect to the first medium. Refractive index of water with respect to the air is defined here. So this is the refractive index of second medium with respect to the first medium, and that should be equal to that into what? Sin r. Hence sin I by what? Sin r should be equals to what? Refractive index of the second medium with respect to first medium. This is a constant. It is always a constant. Refractive index of water with respect to air is always a constant. A constant of proportionality is a constant, and therefore we can write this as a constant. We can also write this as what? Refractive index of second medium with respect to refractive index of first medium. Here refractive index of second medium is what? Water. Here refractive index of first medium is what? Air. So this is also called the refractive index of water with respect to air. Please note on this.